Well, good afternoon, everyone. My name is Dave Feldman. I'm the Director of Water UCI, and it's my great pleasure to welcome you to our first Water UCI Colloquium of the 2020 academic year. It is entitled Manageable or Wicked Problems, COVID-19, Viral Contaminants, and Protection of Our Water Supply. Before I introduce each of our distinguished panelists, I want to thank you all for coming. I also want to say that appropriately, this is the first ever colloquium that we have done virtually through a Zoom webinar. And certainly given the conditions we're under in our society right now and the topic of this colloquium, that is all the more appropriate and really hits home the message that we want to convey to you today. A little bit about the logistics. Following some brief remarks by each of the panelists and answers to a series of pre-prepared questions that will be provided by me, we're going to devote the remaining time to audience questions. Time permitting, you'll have the opportunity to share questions in the chat. And just a couple of announcements. Our second colloquium of the year will be next Tuesday, October 27th at 3:30, and it's entitled An Overview of the California Water Resilience Portfolio, which features Nancy Vogel, the director of Governor Gavin Newsom's Water Portfolio Program. We'll also have some future events later in the year on PFAS, a family of contaminants of emerging concern that's been in the news recently, and on water marketing, as well as other topics. Before I introduce the panelists, I also want to thank a number of people who made this event possible. Especially want to thank Han Parker and Naveen Sami from the School of Social Ecology for their assistance in planning and publicizing this event and making possible all of the Zoom logistics that we're benefiting from today. And I especially want to thank Shannon Roback, the Associate Director of Water UCI, for actually assembling this panel and making this happen. And I'm going to also obviously thank our distinguished panelists. Let me go ahead and introduce them. First I want to introduce is Professor Andrew Welton, who's an Associate Professor of Civil Engineering and Environmental and Ecological Engineering at Purdue University. Also want to introduce Daniel Garrity, who's a Principal Research Microbiologist with the Southern Nevada Water Authority, and also a water quality R&D specialist, research and development specialist. I then want to introduce Jim Colston, the Director of Water Quality and Regulatory Compliance for the Irvine Ranch Water District. And last but not least, Mark Sobsey, Research Professor of Environmental Sciences and Engineering at the University of North Carolina at Chapel Hill. As I mentioned at the top, I want to begin our program by first going around and asking each of the panelists to provide a little perspective on how you've come to this issue of being concerned with and studying COVID-19. And if you could just give your perspective for a couple of minutes. Jim, why don't we begin with you?
Thank you very much, Professor Feldman. I so appreciate the opportunity to be here. You know, I really bring I'll call it boots on the ground, pragmatic perspective, representing the Irvine Ranch Water District, right here where UC Irvine is located. And we provide potable water, recycled water, wastewater collection and treatment for up to about 400,000 people in Irvine and then about 5 of the surrounding cities. You can see some of the maps behind me on a daily basis. And so for us, you know, this issue is front and center because folks should be able to rely on their potable water system to provide them safe drinking water every day. So that's really the perspective that I bring to it. We have been working cooperatively with UCI on some research related to this and the SARS-CoV-2. So we'll get into that as the conversation goes on.
Thank you very much. How about Andrew Welton? Your perspective, please.
So thank you for having me, Dr. Roback, Dr. Feldman, and everybody else at socioecology at UCI. My interest is the implications of deserting, low occupancy, or shutting down buildings and allowing water to just sit in them, in the plumbing pipes and tanks while everybody's away. And so our work here at Purdue University focuses on plumbing safety and the relationship between water distribution systems and water safety at the tap. And we've been working with a number of different researchers from around Canada and the US, a number of different organizations around the world really on this issue. And I'm just excited to be here. Thank you so much.
All right, thank you very much. Dan Garrity.
Yeah, thank you for the invitation to participate in this. So I was actually associate professor at UNLV for the past 7 years. And back in June of 2019, SNWA decided to start up a research microbiology group. And so I moved over to the Water Authority back in June 2019 to start up a whole new lab, and it just happened to be right before a global pandemic. And so pretty early on, we decided to start looking into the local wastewater for the virus. Started off as what I thought was going to be a few-week project, and then maybe we'd move back to our normal projects, and I was very naive about that, because here we are many months later still working on that. And so from an R&D perspective, we're looking at it in terms of wastewater surveillance, and then in terms of a drinking water utility, we're also looking at it in terms of a public health perspective. So that's really how it started, was looking in that capacity, and then it evolved into this research project. And then also I'd add, being in Las Vegas provides some unique opportunities for research. So like what I'm sure Andrew will talk about more later is just the hotels, the Las Vegas Strip, with the stay-at-home order that went into a place that had a big impact on our local economy. And so it raises these questions about what do you do to try to bring these hotels back online? And so we're looking at it from a bunch of different perspectives, and we just have the privilege of being able to do it in a very unique place.
Thank you very much. And last but not least, Mark Sobsey.
Hello, everybody. Mark Sobsey. I'm a research professor at UNC Chapel Hill. I was formerly a distinguished professor and retired in 2018 from my full-time job there, but continue to do some research. So I've been doing work on water and wastewater virology since I started my career, which actually goes back many, many decades. I've worked on a range of different viruses in water and wastewater. When the first SARS epidemic occurred in the early 2000s, I worked on coronaviruses in relation to that episode, and did studies to look at the survival of surrogate coronaviruses, because we couldn't work at the time with the original SARS-1 virus, and did studies related to environmental survival and disinfection and those sorts of things. And then when this virus came along, I got involved again. I was invited by the World Health Organization to assist them in developing guidance plans for this virus in water and wastewater. So as I was saying, I've been doing some research related to this virus in a somewhat different context, more related to foodborne exposures from meat, poultry, and fish. But my junior colleagues are also working on things more directly related to wastewater, including this approach to environmental surveillance for this virus. So I'm an advisor on a research project at UNC, NC State, and UNC Wilmington, looking at this virus, and it's looking at this virus, at least its RNA, in wastewater. And I think with that, I'll stop.
Excellent. Thank you very much, panelists. Great introductions from all of you. Before I begin going through our questions, I want to remind all of the attendees that you can ask questions using the Q&A button at the bottom of your Zoom screen. You can do this at any time during the webinar. And then we're going to go ahead and take some of those questions during the last quarter, the last 15 minutes of our webinar. All right, thank you. With that, I'm going to begin with a question. And Dan Garrity, I'm going to direct this to you. And after you've completed your answer, the other panelists, please weigh in as well. The question that I want to begin with is, what methods for tracking coronavirus in wastewater are proving to be most effective, and how easily implemented are these methods by water agencies?
It's a really good question and a tough question to answer because there's a lot of methods out there. So I would say the broadest answer is that there are a lot of viable methods that you can use to implement wastewater surveillance of many viruses, including SARS-CoV-2. Mark and I were part of a Water Research Foundation virtual research summit really early on. I think it was end of April, early May, where we started talking about some of these topics, with methods being one of them. And so just recently, one of the outcomes from that summit was that the Water Research Foundation funded several projects to look at a few different questions, knowledge gaps related to this issue. And so one of the projects was looking at the different methods that are available and trying to do a round robin comparison. And so the results of that will actually be coming out very soon. So you can get an idea of what methods are being used and what methods are effective. From our experience and then talking to other researchers, everybody has their own methods that they've implemented in the past for other viruses. And I think a lot of people use those same methods once this became an issue and trying to implement wastewater surveillance. And I think a lot of people are having success with just about all of those methods. And so I would say it really comes down to personal preference, what method gets implemented, and then also just more practical issues of whether you have certain types of equipment, like an ultracentrifuge, for example, whether you have just regular centrifuges. There's really options for any type of lab to try to implement something. And so really it's just important to try to get started and understand the limitations or just the specific characteristics of a certain method. But really any method can be implemented for this type of application.
Very good. Thank you. I want to give the opportunity for any of the other panelists to also weigh in on this question about tracking the coronavirus and the implementation of these by water agencies. Any comments from any of you?
Yeah, I got a pop-up request from Sunny Jang at UC Irvine. Hi, Sunny. I hope you're well. About this question of infectivity. So it's clear that the methods that Dan described and that are being used by many people in the United States and globally are methods that are targeting the nucleic acid of the virus. The virus has RNA as its nucleic acid. That's readily detectable in wastewater at concentrations that are fairly high, 10 to the third, 10 to the fourth, even somewhat more than that per milliliter or per tens of milliliters. But so far, no one has found infectious SARS-CoV-2 virus in raw wastewater or raw biosolids. So we're still at the point of trying to understand why there's so much RNA present, but we cannot find infectious virus. There are studies from the medical virology infectious disease community that suggest that when the virus, which actually does infect the gastrointestinal tract of some people, gets to the colon, the lower intestinal tract, from the small intestine where it was produced, it's rapidly inactivated by antiviral substances in the colon. And hence, virus infectivity is lost, but the RNA persists. And there are some labs around the world that are looking diligently for infectious virus, but so far have not found it. And I think in some respects, in terms of public health risk, that's good news. It's good news for wastewater workers and biosolids workers who have to handle wastewater. And it's also very good news for the drinking water community because we don't really have any significant evidence of risk from infectious virus in our drinking water supplies, including reuse water, potable reuse water, whether direct or indirect.
Very good. I'm going to ask again, I know there's a number of questions showing up in the chat. We will get to those, I promise, time permitting, but I want to keep on track with our pre-prepared questions. So if we can hold off on answering some of these great questions that are appearing in the chat. Jim, you wanted to make a comment in response?
I would just comment further on that, that the idea of a proof of concept that we're trying to work on is this wastewater-based epidemiology. So we may not be as concerned about, are we talking about infective virus, whether or not we have an early indicator that a community is shedding virus before we start seeing the numbers coming up in the sampling or in the hospitalizations. And so that's a concept that's going around right now within the wastewater community is, can we successfully do this in a timely enough manner that we have some early warning that the virus is starting to increase among the population that we're monitoring for.
Excellent.
So that's the concept that we're working on.
Mm-hmm. Dan, Andrew, do you have any comments on this first question? Anything you'd like to add?
No, I have no comments. I am a avid scientific spectator to wastewater-based epidemiology, and I'm looking forward to seeing the results.
Great.
I would add just one more thing. So talking about some of the applications of wastewater surveillance, what's interesting about the Water Research Foundation Summit that I talked about is that we've all seen a lot of those topics come to fruition. So all these different use cases that were discussed early on have actually shown success in different places. So different universities, for example, looking at dorms and trying to get an early indication that there might be a pending outbreak in a dorm. I've seen success of that in several places. University of Arizona, for example, I believe Utah also. I saw a study out of Houston looking at a homeless shelter and how they're able to potentially stop an outbreak at a homeless shelter by looking at wastewater coming from one of the homeless shelters in town. So in addition to the wastewater-based epidemiology, understanding what's happening in the community, there's more specific uses that have come into play, and it's really shown the power of this tool. And I think we'll continue to see that going forward.
That's excellent. And it's great to see that there's that much progress being made that we can track at that finally. The next question is going to go to you, Andrew. And the question is, what are the water quality risks associated with building vacancies during the pandemic? And along those lines, what other risks does the pandemic pose, in your view, to our water systems?
So that's a good question, and it's been asked by parents sending their kids back to school, parents sending their kids back to college, back into office buildings, wherever you may be going. The issues are pretty much the same as you would expect for buildings before the pandemic: chemical contaminants, heavy metals, as well as microbial contaminants, Legionella, and some other contaminants. And so really the issue is, if we leave water in the pipes longer than we normally do, does that pose a greater risk? Is there a situation that we may encounter where somebody might get sick now, whereas before? And so that's an issue that's still, the question is still being debated right now. I will say, for those individuals looking for the smoking gun or the data set that shows that stagnated buildings are much worse than in buildings under routine conditions, you're not going to find that right now. And the reason why you're not going to find it likely is because the data is being collected and sent to health departments, and they're a little behind on posting that data. And then several of the issues that are being discovered are going into litigation. And so you may never hear about it. And so one of the issues is we're just going to have to wait to see kind of what happened after this pandemic, during this pandemic, to see if water quality got worse and if that had health impacts or not.
Thank you very much. Jim, Mark, Dan, any further amplification?
Well, I certainly agree with what's been said about this issue related to water. And I think the issue for those who have responsibility for these sorts of buildings, including schools, for example, where we're sending children back to schools, is to make sure that if the water, during the first several months of the pandemic, was stagnant, that they went ahead and implemented flushing procedures to flush the lines, test the water to make sure that the water microbiologically and chemically was of good quality. And I think if they haven't done this, and especially if they haven't opened some of these buildings up yet, or they've had to shut them down again because of another wave of infection, these are the sorts of things that should be attended to in terms of protecting the water supplies in these buildings. And I think it's important to do that, especially if the children are going to be allowed to use common water sources for drinking, especially water fountains. Maybe having the children drink out of water fountains in buildings that have had stagnant water in them is not such a good idea. Perhaps it's better that the children bring their own water from home, or that special provision for water is provided at the schools for the children, other than drinking directly out of these fountains, many of which are not necessarily well maintained anyway, especially if they've been serviced by private enterprise, which raises other issues. And there have been problems with these sorts of systems in some parts of the country. I'll stop there.
Great, thank you. Jim, Daniel?
I'll just mention that there is no reported incidents where if you have stagnant water that somehow you're going to get coronavirus. So that's the good news.
Yes.
But Andrew mentioned, that there are the traditional things. You could have heavy metals that are sitting there leaching off of pipes, especially if you had lead service lines. And there's been, of course, historic cases of things such as Legionella, especially in hotels or commercial facilities. And so it is important that people understand how to, reopen these buildings. We put right on our splash page, irwd.com, where we had information about the coronavirus. We explained to folks how to reopen buildings. We linked to the CDC site and all the information that they've provided. That's far more extensive. But it's a fairly straightforward process, and it's not something in general that should be the thing that people should be worried about. But it's a good idea to practice some common sense and follow some simple rules to make sure you have fresh drinking water in whatever you're in.
Good guidance. Daniel?
I think it was just a few months before the pandemic started, whereas the National Academies, I believe, put out a report about building occupancy and reopening buildings and some of the issues related to Legionella. So I think it was helpful in that it put a lot of information out there and put that into increased awareness about that issue. When this started and all the hotels and all the buildings around town started to shut down, I reached out to somebody at the local health district, and they were already on the ball talking to the CDC, trying to figure out when everything started to reopen, what needed to be put in place to make sure that it was safe for people to use these hotels again. And so I imagine it was a lot of the same recommendations that you would have in a normal situation. It's just a little bit more magnified just because of the scale of the shutdown and the length of time. But it was comforting to know that people were already working on this days after those types of shutdowns went into effect.
All right. Well, thank you. Thank you, gentlemen. Third question, Mark, I want you to take the lead on this if you would. What are the major infectious disease risks associated with our water supply currently? And more directly, is there any risk associated with coronavirus in our water systems?
Right. So I'll answer these in maybe reverse order so that we can't really put this matter to rest with respect to coronavirus risks from our drinking water supply. As I said previously, there's no credible evidence that drinking water supplies are at risk of this virus being present in an infectious form, a form that can result in people getting infected and becoming ill. We have reason to believe that there are good explanations for that, which I've already mentioned. The fact that the virus doesn't seem to survive the lower intestinal tract very well, and by the time fecal matter is excreted by people, there's very little infectious virus to be detected. In the literature worldwide, there's still only a handful of reports of people being able to find the virus even in raw fecal matter. And as I said before, no reports of presence in raw wastewater or biosolids, even with people looking diligently. What we are contending with are the usual pathogens that we have had great concerns with for many years. Obviously, those that are not necessarily enteric or fecal related are bacteria like Legionella, but we have others that are also water related bacteria. We have Mycobacterium avium intracellulare, another biofilm associated bacterium. We have several others like that. Acinetobacter is another. And these are concerns because partly we have to recognize the growing importance of more vulnerable populations for whom these bacteria may be a source of risk. So far from community drinking water supplies, this does not seem to be the case. So the main attention is still on the conventional enteric pathogens, viruses like noroviruses, perhaps adenoviruses. We also have, of course, the concerns with the protozoan parasites, Cryptosporidium, Giardia. It's always important that we continue to be diligent about protecting our water supplies from this wide range of pathogens, bacteria, viruses, protozoan parasites. When it comes to the viruses, we still have waterborne outbreaks, which CDC reports for us on an annual basis, and we still see the same pathogens showing up. But we should be mindful of the fact that there could be new ones that show up. Keep in mind, for example, that there are newly recognized enteroviruses that we have seen causing illnesses in children, such as enterovirus D68, which causes a paralytic disease somewhat similar to poliovirus. That's fecally shed. It could wind up in wastewater. And although, again, we seem to be doing a good job of controlling enteroviruses in wastewater because of historical concern for polio virus, we should be mindful of the fact that not all these enteroviruses are the same. Some of them may be more resistant to treatment processes and may be more persistent in wastewater. So we have to have an open mind about which viruses to be on the lookout for in our wastewater systems. Our molecular tools are a big aid in this regard because it's now become easier to look for a broader panel of viruses, especially by detecting their nucleic acid, which can give us, again, an early warning of the presence of these sorts of enteric viruses in our drinking water supplies. I'll stop there.
Excellent. Thank you very much. Andrew, Dan, Jim?
I think that was a great explanation. I would say, just to add, that when we started our project, we have our research group and our compliance group here at the Water Authority. And our compliance microbiology laboratory has been focusing more on the surface water supply, so essentially Lake Mead, our intakes, the Las Vegas Wash, which is the blended discharge from 4 major wastewater treatment plants in the valley. And so over the past, I don't know what it's been, 6, 7, 8 months now, they haven't detected the RNA of the virus of SARS-CoV-2 in any of the samples that they've been collecting since the start of the pandemic. And so I think that kind of matches what we're seeing in other studies where the RNA either gets removed very quickly in the wastewater treatment plant. So even before it's discharged into the environment, we can't detect it with the methods that we're using. So it's possible that that RNA might be there below the detection limits. But so far, at least here in Las Vegas, we have never found it in any of the samples after secondary effluent from the treatment facilities and then out in the environment. So I think that supports what Mark was talking about in terms of the risk associated with SARS-CoV-2 on the drinking water side.
Mm-hmm.
I would add to that something that folks don't think about, but probably the real threat is that the essential worker would become sick and therefore not be available to provide the water supply. And so that was front and center on our minds here with our staff. In the same way with healthcare workers, we need to have PPE, we need to have hygienic practices, and I'll call it practicing work distancing instead of social distancing. We need to provide that environment because, the way that we demonstrate the water supply is safe is by going out and monitoring the storage and the source waters and the distribution system. And so we need the staff to be able to do that. And so it may not be something that people are thinking about, but for us, that's front and center, is how do we keep everyone safe and able to work so that we can provide safe drinking water. And that's our focus for the last 7 months.
Yeah, that's a great point. So yeah, also here at the Water Authority, our operators were essentially put in a bubble that we weren't allowed to go anywhere near them to make sure that we were also always providing water supply for the community, even during the stay-at-home order.
Great.
Yeah,
Very robust.
Mark
Go ahead.
here to add another couple of points in this
Sure.
regard, and also to indicate what some of the resources are, even though they're more wastewater utility directed. So the Water Environment Federation has put together a very informative document, which you can find on their website, about addressing this virus in wastewater utilities. By all the usual means, they've revised their the manual of practice, this MOP1 document. There's a whole new update which addresses this virus in that document. There's also a roughly 68-page separate document that's available from WEF on managing the issues related to this virus in the wastewater utility workplace, invoking all the usual things: administrative controls, engineering controls, and of course PPE, and some of the things that have already been mentioned. So even though we think the risks from infectious virus are low, we have to worry about the fact that workers could be bringing the virus to the utility, and therefore all the usual precautions need to be put in place, and maybe even becoming more stringent, such as, you know, the typical practice of letting everybody eat together communally in the same space. Maybe that's not such a good idea. And if they are going to allow those kind of communal meal times or breaks, people are going to have to still maintain physical distance and take other precautions so that they don't infect one another, including wearing masks, washing their hands, etc.
Mm-hmm. Very good. Yeah, precautions on every front, which is a great segue to this next question, which I'm going to direct first to you, Jim. What is the occurrence of coronavirus in our drinking water treatment and distribution systems? And how is water treated and coronavirus removed?
Yeah, that's a great question. And I believe that Mark has done a good job of touching on this. But to date, we have no reason to believe that it's present. It isn't possible with these systems to, monitor for every potential pathogenic organism. And so we use a system of surrogates, things like total coliform, and we look at turbidity, and then we make sure that we have a total chlorine residual. And yes, we do special studies, and I think Daniel's really touching on that. But we have to rely on our current systems in order to demonstrate that water is safe for folks to drink.
Thank you. Anyone else want to weigh in on this?
Mark here, I'm going to put in a pitch since, as many of you know, in our drinking water systems, the only thing that we routinely measure are the traditional fecal indicator bacteria, which are total coliforms and E. coli. And what we know is that some viruses are more resistant to water treatment processes and disinfection processes than those bacteria. However, the good news is that if we look at the scale of or range of susceptibility of pathogens to various stressors in the environment, including treatment processes, wastewater treatment processes, these coronaviruses, these enveloped viruses, they're the most sensitive. They're the least resistant. So even monitoring for E. coli and total coliforms is probably a good indication that if you can be in compliance with those, you're probably not going to have a problem with this virus. It would be different if it was a very robust and resistant virus, but thankfully it's in the class of viruses that are profoundly susceptible. And even our fecal indicator system, as imperfect as it might be for some of the human enteric viruses, is probably doing good service and providing reliable information for us about about the risks from this coronavirus.
Good news indeed. Andrew, Dan?
Yeah, I would like to just add, this pandemic has brought together the plumbing industry with the public health sector, with researchers, with parents, with some of our family members asking if the water's safe when they go back into the building. And so this has been really a catalyst of scientific discussion in somewhat public awareness of what we know and what we don't know, and the standards and things that we rely upon to have safety in water in buildings and stuff. So not just coronavirus, but I think, we are in a better place scientifically than we were before because of just the collective energy that's gone into trying to help. And that goes back, I think, to the mission of what we are, civil environmental engineers driven by public health protection. So I just wanted to put that out there. And this is a really amazing time.
Good to remind us of that. Thank you, Andrew. Daniel.
Yeah, I'd give a shout out to Mark and to like Chuck Gerba, Krista Wigginton, Kyle Bibby. There's a lot of research on other viruses that are similar to SARS-CoV-2. And so when this happened, we were able to tap into a lot of that existing knowledge and literature to not necessarily know exactly what was going to happen with SARS-CoV-2, but to have a general idea of where this fits in terms of resistance and susceptibility. So like Mark mentioned, by looking at that literature, we had a good idea that this was not going to be a super virus that was going to tax our infrastructure, and that our existing treatment processes would be able to handle it. And so that was really helpful in trying to reduce the uncertainty around this.
Thank you, gentlemen. Before we turn to Q&A for the audience, I have one final question, a pretty general one that is directed, please, any of you can answer. We've covered a lot of ground this afternoon, but my general question is, what are some common misperceptions that people continue to harbor about drinking water and coronavirus? And are we doing everything we can, you think, to address these misperceptions? Or what more do we need to do to educate the public? Anyone?
I'll tackle this. So I think a lot of the misconceptions may be surrounding this issue of the very important, very useful attempts to do wastewater-based epidemiologic surveillance by detecting the RNA of this virus, which we find in reasonable abundance and is a very useful tool. But people may mistakenly think that this is indicative of the presence of infectious virus. So we have to keep reminding people that even though we can detect the nucleic acid of this virus, we're not detecting infectious virus. If you think of it as, and it's Halloween, so this is this is probably a good time to bring it up. What we're detecting is kind of the backbone of the virus, the skeleton of the virus. So it's just a skeleton. It's not a fully articulated, scary agent virus that's going to attack you. So it lacks all the essential parts to make it an infectious virus. That's never going to happen. And that's the good news. And the Water Environment Federation information that's been put out to the wastewater professional community is very clear and specific in this regard. It's a good resource, and I think with their permission, this could be transferred over to those in the water utility area because it's equally relevant there, and it provides a good resource from which they can probably get permission to utilize that information and assure the public that just because we can detect the RNA of this virus in wastewater, we're still not looking at the presence of infectious virus in drinking water, and don't confuse one with the other. They're quite different. It's only a skeleton, not a real scary agent like the ones that you recall from the Halloween shows, like Halloween.
Excellent. Others? Jim, Daniel, Andrew?
Yeah, I would mention that when you talk about misconceptions, people have heard, oh, it's the novel coronavirus, and how it is very deadly, especially under certain circumstances. And so I think they associate with that with, well, maybe we can't treat it. And I think Mark did a good job explaining that no, through our current water and wastewater treatment systems, we can treat and remove or inactivate this virus, just like we've been doing for a very long time. And so I think that is a misconception, and one that we need to correct out there, that our water systems are hardy enough to handle this.
I don't know if it's a misconception that I would say, but just the fact that researchers were not secretive. Like I can't. It's been amazing
Right.
to see how much collaboration there's been immediately. So once this started, just informal groups getting together, like I mentioned several times, Water Research Foundation leading that virtual summit, hundreds of people getting together to try to tackle one problem. And so the amount of progress we've made on this topic alone in such a short amount of time. So if anybody who has written a proposal before, when you're coming up with an idea for a project, it might be 4 or 5 years before you have data that you're ready to publish. And just in a 8-month time span, there's been so much great research that's been done. And so there's a lot of researchers, a lot of scientists that are utilities, operators, everybody's been involved in this. So it's been really comforting to see that.
Great. Any further thoughts on this?
So I'll put in a pitch to the academic community, since this is sponsored by UCI. So as we know, because of the risks of this virus and the risks in working with it, the only labs that can really look seriously for the infectious virus, even if they wanted to do that in environmental samples like water and wastewater, they would have to be biosafety level 3. There are such labs in academic institutions. They tend to be largely dominated by the needs of the infectious disease community, with good reason, because they're trying to address profound issues related to controlling this virus with vaccines and therapeutics, and doing basic research to better understand this virus. But it would be great if some academic institutions could in fact designate BSL-3 laboratory space for environmental studies. That would provide, I think, a good resource to tackle some of the questions that we would like to be able to directly address on this virus, specifically this one, rather than the surrogates. Because if we could work with this virus, we could study it for response to free and combined chlorine, to UV disinfection, to other to ozone and other processes. And I think that would be a great help in advancing our research to make sure that we do the studies that would sort of confirm and reaffirm what we have been assuming, which is the data we have on these treatment processes for the other coronaviruses indeed are directly applicable to this new virus that has emerged.
All right, very good. Thank you. Thank you, gentlemen. I want to begin with a question that just came in, and I think it's relevant to the work that all of you are doing, but I'm just going to pitch it out there. The question is, has the Centers for Disease Control published guidelines for the proper flushing of water lines for buildings, which have been shuttered for several months? Most concerning are school buildings. Andrew, this seems to be right up your alley, but I'm going to ask any of you to answer this.
I'll start. So the CDC has done a good job in trying to get their hands around building water safety, in preparing buildings for reoccupancy. Early on, they were a little slow to the gun because they were focusing on the priority, which is saving lives and COVID. And because of that, there were over 65 different guidance documents issued by the CDC, the EPA, different state agencies, different county health agencies, different utilities, different consultants who went to utilities and schools and such. And so there's really just a conflicting amount of information about what to do. So today, the CDC has a guidance document on their website that gives some overall ideas for how to flush buildings, but you can't operationalize it. And so what you really need to do now is work with people that understand the building pipe and layout and figure out how to flush the building. And so there's very inexpensive ways to do it. It's kind of like flushing a utility distribution system. You know, we don't go to one hydrant and open the hydrant and assume that the entire piping network under the street is empty. There's a way that you get all that water out, and that's the same concept you have to apply for buildings.
Mm-hmm. Any other thoughts? Any panelists?
Yeah, Mark here. I think, as has been mentioned, lots of different entities, credible ones, have weighed in on this matter, including US EPA. So I think they would be another good resource, especially because they're not only a regulatory agency, but they also provide technical support. And then you also have the plumbing industry or the related industries that deal with buildings, like IAPMO, the organizations that are intending to address these issues related to water in buildings. And they could potentially be good resources on this as well. The hope is that their information would not be really in significant conflict from one source of advice or one source of guidance to the other. But I think it's good that there are these multiple resources, and I think it's probably in the best interests of the public and the communities to consult all these resources and then use that information to make strategic decisions about how to address this issue best in your own building systems in your own communities.
Thank you. Any other thoughts before we go ahead?
I'll just mention that, you know, to affirm what Andrew was saying, and that we do have that CDC link on our irwd.com website. So if someone wants a faster way to find it. Otherwise, you might get lost in the morass of the cdc.gov site.
Good point. We want to make sure that the information is accessible and useful. All right, let me go on to another question. This is a question from one of our participants in the audience that asks, what viruses are typically screened for in water, given the fact that we want to be responsive or open to other possible viruses in the water and continuing to look for them? I think there's been a partial answer given, but maybe it'd be good to just kind of focus on that. What do we typically screen for?
So as you know, there is not a requirement to do routine monitoring for viruses in our drinking water supplies. Periodically, we have had some special studies done. We had virologic studies done on drinking water supplies back about 20 years ago. And this was part of the so-called Information Collection Initiative, or ICR, in which they were using primarily culture-based methods to detect enteroviruses. So there is some capacity for some utilities to do this kind of virus monitoring. It's not done on a routine basis. But what is underway, looking at the development of criteria and potential standards for coliphages. These are bacteriophages of E. coli as fecal indicator viruses. Coliphages have been well studied for many, many decades. They've proven to be valuable fecal indicator viruses in many different contexts. The European Union has adopted coliphages as drinking water indicator viruses. And I think there's good reason for the United States to consider adding this to our toolbox of how we monitor drinking water supplies to address virus issues. So the methods are already available. They were developed for the groundwater rule. This was the groundwater rule that was developed again about 20 years ago, in which there was a concern about the presence of viruses in groundwaters because they're tiny and they could penetrate into aquifers. Methods were developed. These are EPA methods 1601 and 1602. So we already have virologic methods. They have been modified and updated and adapted to wastewater and recreational water monitoring by US EPA. And there's a new method that's available for that in addition to the previous ones I've already mentioned. So we're kind of moving in the direction of developing a virus indicator system. And I think there's good reason for us to embrace this rather than resist it. I know there's been some resistance because, you know, it does add some cost to the monitoring, but it's no more expensive to monitor for these coliforms than it is to monitor for E. coli and coliforms.
Mm-hmm. Other thoughts?
I'd say, particularly in California, with all the potable use projects going on, one of the things that was realized is that there's not a huge data set for, let's say, focus on viruses. So viruses just in raw sewage. And so there was a big effort from the California State Water Resources Control Board to fund some of that research so that we had a better understanding of what are the typical concentrations of things like adenovirus, norovirus, and enteroviruses that you find in wastewater so that we can more appropriately design treatment trains to do indirect potable use and then ultimately direct potable use in the future. And so that was actually in effect already before this started. And so it increased awareness of this issue. And I think it actually made people better equipped to engage in wastewater surveillance for SARS-CoV-2 once this started. So it actually good piggybacking effect in that respect.
Okay. Let me go on and move to another question. This is kind of an interesting general question. It's not one that immediately perhaps comes to mind, but we've been talking about the coronavirus in water. One of our participants asked, for those who participate in active sports, it's been decided that drinking fountains are a touch point. So they've been capped in many communities, and now there's no water available, particularly for active citizens, active seniors, for example. Is this a sensible thing? Is that in fact really a measure that should have been taken or should be continued to be taken during the pandemic?
I'll take a crack at addressing this question. I think based on the information we know about the presence of this virus in saliva and sputum, infectious virus, and the fact that that people are shedding this virus. Obviously, that's how it's mostly spread, from cough, sneezes, talking, singing, etc. And the numbers can be fairly high. In saliva, the concentrations are in the ranges of maybe 10,000 per milliliter. In sputum, they're even higher by a factor of 10 or more. That is 100,000 viruses per milliliter. So if you have communal use of water fountains, then some of that virus from saliva and sputum could get deposited on those water fountains and could pose a risk to those who would come after them. Also, they could have the virus on their hands if they're infected, and that means that if you're touching the press button or the handle on the water fountain, that's a risk. So it's regrettable, but that means that if you're an outdoors person, you're probably going to have to carry your own water with you during your activities of that type, your sports and exercise activities of that type, because it may not be such a good idea to just try and get water out of these communal sources like fountains.
Thank you. Any other further thoughts on this, Andrew?
So this was, I got called by parents whose schools shut down their water fountains, and they had asked why, and CDC at one point had guidance on their website that said, shut down the water fountains. But they had changed it a little bit and made it more clear. And I completely agree with Dr. Shabsi's approach and the public health significance of the exposures for coronavirus. But one of the unintended consequences was that the schools, by law, had to provide water for lunch. And then they had to go buy expensive bottled water, many of them did. And this was an added expense in addition to retrofitting the school for controlling ventilation and social distancing and online learning. And so there's just been a number of different downstream consequences of decisions, and it kind of helps show what one decision does to these other issues that we don't necessarily think about all the time, but I think now we do.
So one thing that I think should be looked into more aggressively and technologically, because you already see these in some places, is that in some of the water systems in public places like airports, there's not only the fountains, but then there's the provision where if you have your own bottle and you put it you put it in the right place, then your own water bottle gets filled automatically because the sensor detects the presence of a container, and you don't have to touch anything. It's a no-touch system, and you can fill your own bottle. Those kinds of systems would be good substitutes for the use of fountains. And yes, it's an investment in a different type of water delivery technology, but it's worth considering in situations where it may be difficult to just provide enough bottled water to those who need it, particularly in schools.
Great point. We're getting close to the end, so I want to just focus on a couple of more questions from both the chat and from the Q&A. And this is, again, another from a general question, but I think really points us in some directions in terms of future work. What type of pathogen or what pathogen has proven to be the most problematic in our water supply and has resistance in pathogens developed over time to water treatment methods, that is, resistance to water treatment methods developed over time? Anyone?
It's a great question. I would say, if we look at what causes waterborne outbreaks, we can prioritize based on the ones that have been most problematic. And lately, Legionella bacteria have been prominent. They've been prominent both in drinking water supplies and in recreational water. Whether or not these kinds of bacteria, Legionella, Pneumophila, and the others, are changing in terms of their resistance, I don't think we have good evidence for that, although I don't know how carefully that's been studied from the standpoint of the infectivity and virulence of that particular bacterial agent. When some of these issues come up, what we do know is that some bacteria can become more resistant because they change their properties, such as an outer layer of protection, such as the bacterial capsule that's present on some bacteria, that makes them more resistant to disinfection, for example. So the classic example of this is Vibrio Cholerae, which thankfully we don't have in this country with the cause of cholera. We don't have waterborne cholera in the United States, although globally it's a huge problem. But what happens is that the cholera bacteria that have the capsule become more resistant to chlorine, disinfection. That's well documented from literature that goes back to the 1980s. But in addition, these kinds of bacteria evolve over time. So new strains of Vibrio cholera keep emerging. And we should be on the lookout for this, for some of the other bacteria that are just more, shall we say, abundant and present in the US, including bacteria like Legionella, Acinetobacter, and some of the others that we know could be of concern, mycobacteria as well.
Very good. And the last question before we close up, and I have just a couple of announcements. It's a great question. I'm going to kind of rephrase it to maybe summarize it a little bit. I think the essence of the question is the trade-offs between wastewater surveillance as a detector of COVID-19 versus spending resources on testing individuals and contact tracing. Is there a trade-off? Should we be, are we putting too much emphasis on trying to detect it in wastewater and perhaps not enough on contact tracing? Is there some sort of a balance that we ought to try to strike?
Well, certainly it's not a substitute for the work that needs to be done from a public health standpoint. That needs to be front and center. This is a way to see if we can get an early warning system in place that could help us to tell our communities that we may need to, practice better social distancing, et cetera. I mentioned we serve up to 400,000 people a day. So for us, if you're looking at the scale there, that's peanuts compared to that level of population for testing.
Right.
So my I guess point of view about this is that we should be intensively applying both approaches, both the wastewater surveillance approach, because it provides useful information as an early warning system, and it can be done at a community scale or building scale. But in this country, we have to do far better testing of people and model the systems that we would be using on those that have been used successfully in other countries, like Japan. And those countries have done a far better job of containing the virus. Australia is another one, New Zealand another one. And they did this by attacking the virus early on and doing the traditional things of early detection of cases, isolation, contact tracing, and those kinds of intervention measures. We're kind of behind the curve here on this in the United States, but it's never too late. Our public health officials keep calling for this, but so far we have not invested enough resources in trying to get ahead of this virus instead of catching up.
Good sobering reminder. Thank you for that. Before we close out, before I thank the panelists, I do want to remind you two things. And Shannon, thank you for posting in the chat as well. This colloquium has been recorded. It will be on our website soon and also on the YouTube channel. So this is going to be around for posterity, and we're very, very pleased that it's been such a wonderful panel and great information to share. Next week, we're going to have our second colloquium, which is an overview of the Water Resilience Plan, California's Water Resilience Plan, featuring Nancy Vogel. Do we have can we go ahead and post the flyer on that? So that'll be next Tuesday. This has been a tremendous panel. This is, again, the first virtual colloquium we've ever done in Water UCI. It most definitely will not be the last. There can be several more. Cannot thank the panelists enough. Jim Colston, Daniel Garrity, Andrew Welton, Mark Sobsey, thank you for joining us. This has really been a tremendous event. Those of you who have continued questions, don't hesitate to contact panelists individually or collectively. I'm sure they'd be glad to hear from you. Thank you. Thank you very much.
Absolutely. And thank you for allowing me to participate.
It's been our pleasure. Great honor.
Thank you.